Hi everyone. Next I want to jump back into some of that graph stuff I worked on in the intro video. It's really important that you have a good mental picture of what these things mean. So I want to look at x values and y values in function notation and how we would represent lengths, slopes, and areas. The area is more of a Calc 2 thing, but we're probably headed that way, at least a lot of us. So bear with me. It will be really important, and all of this is good for your visualizing for Calc 1. Okay, so I'm just supposed to go through the list. I have a pair to start with. I have c and g of c. So this is my function g of t. And instead of giving numbers, I'm just saying, okay, this is x equals c, already represented for me on the x-axis. So what does that mean that I put a tick mark right here for x equals c? It means that the distance from the y-axis to that point is c. So c is a length, and it is in fact that purple length I just drew. It's a horizontal distance from the y-axis over c units. Contrast that with g of c, and this is like what we did earlier. G of c is your y value, so this is a vertical distance. We're going to start from c on the x-axis, and we're going to go up. And note that there's an open circle there that's kind of tricky. An open circle means there is not actually a point there, so I'm not hitting the function when I get there. I just keep on going up, and I don't hit the function until I get to the closed circle. So this entire distance right here is a g of c. So that's the first pair, and that's going to be the building blocks for everything else. So those are both lengths. One I picture horizontally, one I picture vertically, but they are both lengths. Okay, part B, we're going to start with that, and then we're going to go a little bit further. So D is also going to be a length. It's going to be an x value. I know that because I see it right here. So D is this length right here. Notice technically you don't even have to draw that right on the x-axis. You can draw it anywhere, but keep it horizontal. And the reason for that isn't because you couldn't draw a length vertically. It's because the scale is different. Notice how big one is on the y-axis versus one on the x-axis. So we would have to adjust for that, and that's just way extra complicated. So let's not bother. Let's just visualize that as a horizontal distance since it's already marked there and say that is length d. G of d is going to be the y value that goes with that x. So there's my g of d. Also a length. And now we're going to get into some of the more interesting stuff. What happens if you multiply a horizontal length by another vertical length? Let's not say another. And the answer is basically what we've done is we've built up the sides of a rectangle. If you think about a rectangle, if you multiply its base length by its height or width, however you want to think about that, what you're getting is the area. So when you multiply two lengths together, you should be able to interpret that, especially when one is horizontal and one is vertical, as an area. So right across here, I'm going to just close off my rectangle and say, let's see, do I have a green highlighter? This area right here, that is d times g of d. Oh, I can even spell area sometimes. So if you multiply two lengths, you should at least be considering that that might be representing an area for you. When you divide two lengths, that can be a little weirder, but one way you can always interpret it, again, especially if the top is a vertical distance and the bottom is a horizontal distance. If that's true, and it is true here, you could be looking at a slope. And this one actually I think is kind of extra tricky that I started with because you don't see the minus. You don't see g of d minus g of c over d minus c. So my explanation for that would be, okay, here's my point, dg of d. For the formula to not have that minus, the other point would have to be 0, 0. So if we think about this as g of d minus 0 over d minus 0. That's the same as what we started with. That's how we could interpret that as a slope. So if you take a vertical length and you divide it by a horizontal length, you could interpret that as the slope of a secant line. Hopefully we'll be able to see that. In this case, it's the secant line through D, G of D, and 0, 0. So I actually think that's trickier than if we had a second point that was more obvious. But that's what I would say. If you see a division, see if you can interpret that as a slope. If you see a multiplication, try to interpret it as an area. Okay, last one here is making a little bit different point, and then I have another set for us. D plus 1 and G of D plus 1. I'm going to erase just so that we can see our ones a little bit easier. Let's see here. Oh, I guess I could have left that. So if we go back to those highlights I had, this is really important. Scale is super important, and this is why it's a really big deal that you always label it for me. One doesn't necessarily look the same horizontally and vertically in the XY plane. It depends on your scale. So if I want D plus 1, here's my D, I need to add 1 to it. So I'm visualizing this length right here is 1, and I'm just going to carry that over. I have to approximate a little bit, but I'm going to try and carry that over as much as possible and say, okay, if I have D, and then I add my 1 onto the end of it, then this entire length right here is my D plus 1. So it matters very much that D was horizontal, so I need to be adding 1 from the x-axis onto that. Okay, and then G of D plus 1 versus G of D plus 1 with parentheses in different spots. So those are both important as well. So we'll start with G of D plus 1. That says your x value is D plus 1, which we just found. So this really is related to what we just did. D plus 1 on the x-axis is right there. If we want G of that, we're going to go up and we're going to say this is G of D plus 1. So we added 1 to our x value. If we want G of D with a plus 1 to the output, remember G of D is a y value. So that's the y value at D, and then we're going to add 1 to it. So we're adding 1 to our y value. So first we need to say, okay, here's D, which means this is G of D. And then we need to add 1 onto that. So I'm looking at this one right here, vertical now, and I'm going to try and estimate that to be about like that. That's what my 1 looks like. So, back to red. That's adding 1 to my output, so adding 1 to my y. And this is G of D plus 1, that entire length. So it's very different whether you add 1 to the input or 1 to the output. You can see that orange vertical distance and that red vertical distance are not the same. Okay, just a couple more groups to look at. Let's go back to our blue, look at G of A, G of B, B minus A, and then a couple more. These are a little bit close together. Those are supposed to be separate. Okay, so where's my A? My A is way out here, which means G of A is that vertical distance, and G of B, B is right next to it, is this vertical distance. Okay, B minus A. B and A are both x values, so if we're imagining we have this whole long length B, and we subtract off all of this A, so all of that kind of green disappears because we've subtracted it off. All that's left is this little bit in the middle. So the difference between B and A is like the distance between B and A. Give or take, the order could make it negative, but otherwise that's what we're looking at. So that's B minus A. Okay, so those are all the building blocks, and then I have two things I want to look at. One, if I take that length B minus A and I multiply it by G of B, what do I get? Remember, if you're multiplying two lengths, you're getting area. So I'm saying this is like the base, and then G of B, this is like the height. So I'm getting, when I multiply those, the area of the rectangle with that base and that height. So this right here is my B minus A times G of B. I highly recommend, as you're working on homework or taking notes or whatever, if you have some highlighters or some colored pencils, use them. I find them extremely helpful in calculus. Okay, and then one more. I'm sorry. These are actually one big group. I have them on two lines, but all of these refer back to B and A. So G of B minus G of A. That's saying find the difference between your two y values. So we have this y value and this y value, and when you subtract, what you get again is the difference between them. So this right here should be your g of b minus g of a, the difference between those two y's. And then we want to do a couple of things with that. So now we have that distance, that green distance that's above our rectangle. The first question is what happens when you take that vertical distance I just drew and you divide it by this horizontal distance on the base of the rectangle. And the answer is a slope, but it can be a little bit tricky. That's the slope between a g of a and b g of b. So that's the slope between this point, ag of a, and bg of b. It's the slope of this secant line. So slope is g of b minus g of a over b minus a. And again, I just want you to, whenever you see that, I want you to know that's talking about slope of a secant line. Or if your function is linear, it's just talking about the slope of the line. Okay, and then just one more to push you, and you'll have some of these to try on your own just to make sure you're getting this. What happens if you take that same b minus a, base of the rectangle, and you multiply it by the g of b minus g of a, this green vertical distance? And again, remember, when you multiply, what you're getting is area. So we're multiplying this length right here by the green height, and I did move that up to the top on purpose. I don't want to have it start all the way from the x-axis because then the height of my rectangle would be g of b. In order to make the height of my rectangle g of b minus g of a, I'm just going to tack my rectangle on top right there. So that area right there is b minus a times g of b minus g of a. Okay, give it a try. Let me know if you have questions. I know that can be tricky at first. It's a little abstract, but it's extremely helpful if you get good at this.